Hello everyone and welcome back to another math study guide. This one's going to be pretty interesting as we are going to be finally allowed some calculators here. So I might add images on how to type these things on calculators, so let's get started. This video is all about the trigonometry ratios, and let's start. First and foremost, we need to illustrate the 6 trigonometric ratios. So how do we do that? Let's assume a right triangle. I'm going to draw a right triangle for each of the 6 trigonometric ratios. So this is our right triangle, okay? Let's label this red line over here as theta. Theta is used as the base angle or the angle of this is the angle that you're going to base upon the sides. You're going to name each side of this. So, to name these sides, we need to look. So theta, you want to draw a line over here, and whatever this side is, that's called the opposite. Meanwhile, if you see a line over here, as you could see, but is not the longer side, this is what you call the adjacent. In blue over here, this is the adjacent. And lastly, the longest side is always the hypotenuse. So, it's time to illustrate sine, the main three, sine, cosine, and tangent. So we're going to use the same figure all for these 6, but remember, you can switch theta. So just remember that. Anyway, so first and foremost, let's start with sine. Sine is represented by so. Sine is equal to opposite over hypotenuse. So let's add that, so. So therefore, sine would just be this one. I'll use a different colored number. So opposite. So opposite over hypotenuse. And I'm gonna repeat that for the three others. The two other mains. So once again, we're gonna now do cosine. So cosine is just, I'm gonna re-illustrate the triangle. So just follow the same sides, by the way. So this is still opposite as adjacent and hypotenuse. So we're gonna do that. So I'm just gonna label them by O, H, and A. And this is cosine, or just cos, but I'll say cosine, is equal to co, opposite over hypotenuse. Oh no, sorry. Adjacent over hypotenuse. So, in turn, this is going to be adjacent. So, it's going to be green over here. So, let's highlight that as green. And H, hypotenuse, over here. So, that is going to be our second main trigonometric ratio. The third, last but certainly not the least, is going to be tangent. Tangent is represented by TOA. So ka TOA. So let's do this. So opposite, hypotenuse, and we have the angle adjacent. Then we got theta over here. And then we need to make sure it's a right angle. And then we have to put we're gonna have to highlight in green is our TOA, so O. And then we got adjacent for blue, so that's A. So we just do tangent. So we're going to do tangent equals O over A. So with that, that's our 3 main functions over there. But we have 6. So what are the other 3? Well, we just need to do this again. We just need to change the names a bit and find the reciprocals of each of these what they call this, fundamental ratios of trigonometry. So the reciprocal of sine is cosecant, and it's equal to the same thing but in reverse. So instead of opposite over hypotenuse, it's hypotenuse over opposite. For cosine, it's secant. That's equal to the hypotenuse over the adjacent. And for tangent, it's cotangent. That's equal to the adjacent over the opposite. And that is our six trigonometric ratios, and we are going to be using them for the rest of this video. So I'm just going to keep this over here while I have this table as well over here for the next one. So that's it for illustrating the six trigonometric ratios. We just need to remember all the different formulas. Very good. Okay, so now that we've illustrated the six trigonometric ratio, the reason why we need a calculator is because trigonometry uses very specific numbers. However, for some cases, as in these special right triangles, you can easily use this table to figure out what are the values. So, let's start. I'll explain this. First and foremost, let's try the sine of 0. To find the sine of 0 degrees, we just need to remember the opposite over hypotenuse. Opposite, we got opposite over, sorry, it's 0 degrees, I'm so sorry. But 0 degrees is just opposite over hypotenuse, so obviously it's 0. As you can see over here, 0, 0, 0. It's mostly 0 for sine. How about for sine 30? So we have a 30 over here, so we're going to use that to our ability. So 30, we have here, right? We're going to use this as our theta. So this is our theta. And from here, we have a opposite over hypotenuse. So we have an opposite, that's 1, over a hypotenuse, that's 2. So as you can see, it's drawn over here, it's 1 over 2. Let's repeat that again. We now have a degree of 45. Let's use this as our theta now. We got a sine, so opposite, that's 1 over the hypotenuse. 1 over 1 square root of 2. Or we can just cancel out this one. So just 1 over square root of 2. Remember, in the test, make sure to rationalize. So just do this, square root of 2 over square root of 2 to find your final answer. So, that's how we prove that 45 is that value there. Meanwhile, for 60, we have a square root of 3 over 2. Now let's use this as our theta. So we got opposite, that's square root of 3 over the hypotenuse, so is equal to 2. And turns out, indeed it is. These are the values. For 90, let's just skip that. For 0 and 90, that's just going to be really like okay, let's try 90. You know what? Let's try 90. So we have a 90-degree angle over here. So opposite, that's 1 square root of 2. Oh, wait, this is tricky. Sorry. But anyway, all you gotta do is just remember that these are the values. You really just need the middle part here. Okay, so let's try to prove cosine next, I guess. So for cosine, it's the same thing. So let's try that. So adjacent over hypotenuse. Let's try that. So we have 30 degrees. For 30 degrees, it's just 30. So adjacent, that's 1 square root of 3 here. And we also got the hypotenuse here. So that is square root of 3 over 2. Meanwhile, you got for 45 degrees, let's try it here. We have 1 over square root of 2. So that means this one. So adjacent over hypotenuse. So yeah, indeed it is 1 over square root of 2. Meanwhile, for the cosine of a 60-degree angle, 60, so we got the adjacent 1 and the hypotenuse 1 over 2. Lastly, for tangent, let's prove that again. Tangent is TOA, so opposite over adjacent. Let's start with 30. Opposite is 1 and adjacent is 3. Therefore, tangent 30 is 1 over 3. Over square root of 3, sorry. Then for 45, we got the opposite over here over the adjacent. That's just 1 over 1 or just 1. Meanwhile, for 60 degrees, we got the opposite, square root of 3 over 1 or just square root of 3. So square root of 3 is the opposite, and then we got the adjacent. So that's 1. So square root of 3 divided by 1 is just square root of 3. And to find all of these, you just repeat the same process but reciprocate them. So it becomes 2 over 1 for this one, and then square root of 2, etc. And there we go. Those are the special trigonometric ratios. That's the special trigonometric ratios, and this is the last you can do without calculators. So make sure to bring your calculators tomorrow because they're actually allowed. So there we go, guys. Okay, now here comes the tricky part. We were going to solve different values of triangles based on their only given one side and one angle. Usually this would be impossible, but with the help of sine, cosine, and tangent, it is proven possible to solve these. So I'm just gonna, if you hear some background noise, that's just me getting my calculator, okay? So, as you can see, we have two problems. Let's try to solve them. Okay, let's go. So first and foremost, here we are asked to find the value of AC first. So we have AC. Let's label AC as just X. The length of AC is just X. Now, we're going to use the laws, we're going to use the functions we can use here as our guide. So we have 51 degrees, and that is what we call our theta. First and foremost, we put 51 degrees over here. Now, over here in this blank spot, we're going to either write sine, cosine, or tangent, or sin, cos, or tan, based on what we think is appropriate. Let's try to figure this out. First and foremost, let's draw a line from A to just going straight. And as you can see, we hit here, BC, which means we're dealing with 9, which is an opposite. So this line is an opposite because A is our theta. So we're dealing with an opposite. And then we also have AC, which is closest to this angle, which means this is an adjacent. So we have an opposite, which is this one, and an adjacent, which is this one. Now, let's write that as a term. So opposite over adjacent is equal to tangent. So we're going to write tangent over here. Now, what was tangent equal to? Well, first and foremost, tangent is equal to opposite over adjacent. So do we know the opposite? Yes, that's 9 inches. So we can put 9. However, do we know the adjacent? No, we don't, and that's labeled as X. So we're just gonna put X over here. Now, all you have to simply do is to find X by changing the equation into X is equal to 9 over tangent of 51 degrees. I'll put degrees so that we can easily see it. So let's put that into our calculators. 9 divided by tangent of 51 degrees. I'll show you a picture of it, but it looks like on the calculator, you should have something like this. On the calculator, you should have typed something like this, or you can replace this division sign with a fraction symbol. So it's either this on the calculator, or if your calculator is capable of doing it, you can do this. You click that equal sign, and it's equal to about 7.288. But we usually round up to the nearest second decimal place, so it's 7.29. So therefore, AC is equal to 7.29 inches. Next one, let's try to find the length of AB. So we now know the hypotenuse. Let's try to find out the exact value of AB. So to find the hypotenuse, we obviously have to use a function that uses the hypotenuse as the one of the components. However, this is an estimation and this should not be used. So it might be inaccurate and your answer might be wrong by a few hundreds or even thousands, which could lead you to getting deducted. So instead, just go for the opposite and then find the hypotenuse. Opposite over hypotenuse. That is sine. So this time, copying that, we have sine is to 51 degrees is equal to, we know the opposite is 9, but we don't know the adjacent, so that the hypotenuse. So that's x. Rewrite the structure by putting 9 over sine 51 degrees. And then we can plug that in. X equals 9 over sine 51. Then we can plug the same thing to our calculator. That's just 9 divided by sine 51 degrees. So we can also type that. Let's type that. 9 divided by sine 51 degrees is equal to 11, approximately 11.580, or just 11.58 inches. So therefore, AB is approximately equal to 11.58 inches. Approximately, sorry. And now, by simple terms, we can actually find angle B. We can actually find angle B by just, reducing this, like a 180 and then you do 90. You just have to subtract 90 minus 51, but we're gonna try to find it using trigonometry. Okay, so let's try this. We got the, so what do we have? We already know the, over here. What could we use here? So the obvious answer is obviously 39, but how do we get that approximation? So we can use our rough calculations now, I guess. And this is where another function comes in. So to find angle B, let's just try to use the adjacent over hypotenuse, because that seems the easiest. Adjacent over hypotenuse. So you can say that we don't cosine of something is equal to, something degrees is equal to 9, that's the adjacent, over the hypotenuse, which is 11.58. Now we just need to do 9 divided by 11.58. Let's type that in our calculators. 9 divided by 11.58. You get about 0.777, which is just 0.78. Now from this, you might be wondering, what should we do? Now, we have to introduce a new function. I'm pretty sure you can find a cosine raised to -1. I want you to click possibly shift on your calculator, cos -1, and click just your previous answer, which is this one. So we can type cos -1 multiplied by your answer. It has to be the exact answer, so you can't just put times 0.78. It will result in an error. And after plugging that in, we do get 39 degrees. Yeah, we get 38.994. So we were really close, and indeed the answer is 39. So that's our first example done. We're going to repeat the process. This is our thorough solution. We have another problem here. So let me just take a break and I'll be back in 2 minutes. Okay, so I was basically recording this, but I think it crashed. So I'm just going to explain the solution for this one. So we have the length of xy. So we need to find the length of xy given these points. Xy is a hypotenuse and we're given a adjacent. So an adjacent and the hypotenuse, the best thing to use is cosine. So just typed in, I just put here cosine of 28 is equal to 6 over x. That's just 6 over here, adjacent over hypotenuse, which is unknown. Then I rewrote it as 6 over cosine 28. That's what we did in the previous one. And we got that xy is approximately 6.80 inches, or 6.795 to be exact. Now, we have a different case for xz. We usually have the unknown at the denominator, but what if it's in the top? What if it's in the, what if it's in the top? What if it's in the top of the fraction? Well, what if it's in the numerator position? Well, instead of dividing, we do just simply times that. So that's what I did over here with xz. So xz, we want xz, so that's an opposite, and we have the adjacent. So TOA over here, that is opposite over adjacent. So we just do tan 28 degrees multiplied by 6, giving us the answer of xz is equal to about 3.19 inches. Alright, let's solve for angle A using the ratios now, instead of just solving for this. Now let's type in our estimated values. We may run into some small discrepancies, but that's okay usually. Usually with this one, it's okay to use discrepancies unless two sides are given. Let's start. So angle A. Oh, sorry. Angle A. Okay, I'm just gonna say it's angle X. It's angle X. Sorry about that. This paper is a little bit confusing. So angle X. Let's try to prove that. So let's go. We're going to use the adjacent and hypotenuse over here. So adjacent and hypotenuse. So that's cosine. And so we have the adjacent, right? We have the adjacent, which is 3.19 over 6.80. So cos of something is equal to this. That's equivalent to about, so let's type it down, 3.19 divided by 6.80. That's about 0.47. So we just need to plug this in once again. Cosine raised to -1 times answer, which is just approximately 0.47. So type that. So we go shift on the calculator. We do cosine raised to -1 times the answer, and we get slightly above 62. 62.02, or just 62 degrees. And there you have it. That is our two problems. I hope you get the gist of it. I've done a more thorough one for 1 and a more speedrun version in number 2. Alright, we're actually surprisingly almost, well, halfway done. So let's just box that. And let's move on to the next topic. Okay, we're moving on to the fourth and technically fifth. Yeah, this is technically the fourth and fifth combined. So we're now going to be using real life problems as well as the angles of depression and elevation. Let's start with problem number 1 over here. The angle of elevation from the top of the building, from a point 30 meters away, is 65 degrees. Let's draw that. Remember, you're the person over here. Let's say that you're the person over here. The angle of elevation, it means that you have to go up. Like you have to rotate this arm like this, like this, like this. And you have to ensure in this case that the angle you form is 65 degrees. So let's just draw a 65-degree angle, approximately. Okay, I think this is roughly a 65-degree angle. So let's label that 65 degrees. Then we also have a building. We need to find the height of this building, but we also do know that this is 30 meters. So we have the top of the building from a point 30 meters away. So this is 30, and then we need to find the height of a building. Let me just solve this real quick on my notebook, and then I'll get back to you. Okay, so now that we've tried this, it's kind of hard to see the right triangle now, But let's try to identify first what do we have here. So first and foremost, we are looking for, we have theta over here, and as you could see, we are looking for the opposite. So we can write opposite over here. We also have the adjacent side over here, which is A. Perfect. We have tan is raised to 65. 65. Tan 65 equals opposite over adjacent. Let's rewrite this. Tan 65 is equal to, we have the adjacent, that's 30, but we do not know what the opposite is, so let's call it x. And since the unknown is at the numerator, we simply just do tan 65 degrees times 30. Tan 65 degrees on the calculator times 30. Oh. That's equal to about 64.34 meters. And that's your answer right there. And this is the illustration. Now, you know what? Let me just draw the building real quick so that I don't get minus points. So that we all don't get minus points on the test. Let's do that real quick. And I'll just draw like a little door over here. Let's draw a little door over here. I think that's good. We definitely know that's a building. Maybe a person here as well. Okay. So basically, we know now the elevation. But what about the angle of depression? If an airplane that is, let's do this sentence by sentence. If an airplane that's at a cruising height of 9 kilometers, let's focus on that. So we have an airplane over here to the ground. That is 9 kilometers. Let's just put 9. Then we also have a angle of depression here. So let's just draw a little horizontal imaginary line, shall we? So here, and this is the imaginary horizontal line. Okay, so instead of the angle of elevation going up like this over here, instead of the angle of elevation going up like this, we actually have to go down and create a line over here that connects all the way to the ground. Then let's label this as 7 degrees. 7? Yeah, 7 degrees. We have labeled this as 7 degrees. And then we also have this as 9 kilometers. Okay, we can also say that this is 9 kilometers because this is a rectangle. This is an imaginary rectangle over here. Okay, so based on this knowledge, let's try to find out what is the value over here, the red line, and the horizontal distance. We can also solve for both of those. So I'll be right back just to make sure my solving is correct. Okay, like I said, this problem was really confusing as when I was answering a formative test, it's a bit of confusion. So we're actually looking for what this dotted line is. We're not looking for the red line. So sorry about that because really it is confusing. So instead, let's highlight this line instead. There we go. All right, so given that we have we want to find this red line called x, and we have 9 kilometers over here, 7 degrees, what should we use? Once again, we have an opposite over here, and we have an adjacent. So once again, we're using tangent. So we're going to type tangent. Oh, that's a bit too thin. We're going to use tangent. That's going to be tangent 7 degrees is equal to, we have opposite 9 over adjacent, which is x. We don't know what x is, so TOA. So we're gonna do x is equal to 9 over tan 7 degrees. We're gonna plug that into our calculator over here. So 9 divided by tan 7 degrees. And we do get about 73.30 kilometers as our answer. And that's our answer. That's our answer for this problem over here. And this is the illustration. Let me just draw a plane. Okay, let me just draw. No, that'll do. Okay, it's roughly a plane. It's roughly a plane. Okay, that's the plane. Okay, that's the plane. So that's what you should draw as well. So on the test. So yep, we have illustrated the angles of elevation and depression, and we use the trigonometric ratios to solve real life problems involving right triangles. And there it is. That's the entire review. It's only for 40 minutes, so you didn't really expect it to be that long. If you have any more questions or any more problems that you need to solve and still don't get it, feel free to DM me on Discord if you know, and Instagram if you also know. Anyway, once again, make sure to please take care of yourselves. We're getting bombarded with tests. It's nearly the end of the year, so yeah, good job everyone. Good job. Thank you so much for watching. But before I leave, I do need to tell you guys something. So, I've noticed that all of our math grades have been a little off lately for the second trimester, and I want all viewers from my class and my classmates, my batchmates, I just want 5 to 10 minutes of your time. So, I want you to request your parents or maybe yourself to write a letter to your math teacher regarding if we can have extra cerebri points or supplementary cerebri activities to pull up our written work scores or our assessment scores. I know it's the last term of the year, so we want to end it off with high grades. I believe that we should have incentives because not only does it allow us to learn from our mistakes and see what we did wrong during the assessments themselves, it also allows us to have the grades we want and achieve our goals easier. So in conclusion, it's a win-win situations because we are learning from our mistakes and we are getting the grades we want. And for the teacher, well, it just assesses our performance, and the teachers can be focused on some topics that the students are struggling in. So, I apologize for the little bit of request, but once again, I spend 6 to 12 hours sometimes making these videos. In this case, I've made it for 2 hours. So, once again, thank you so much for watching, and I'll see you guys on the next one. Take care of yourselves. Goodbye.